This is my midterm in microprocessors. Introduction. Imagine a world where machines can not only think but predict, simulate, and even create realities faster than ever before. At the heart of this transformation lies an innovation that started as a simple graphics accelerator, the GPU. Today, GPUs drive artificial intelligence, power real-time simulations, and fuel technologies in shaping the future, from digital twins to the metaverse. These innovations touch every aspect of our lives, from how we work and play to how we solve global challenges like climate change and healthcare disparities. In this reflection, we will dive deep into how GPUs evolved to dominate computing, their critical role in AI and beyond, and where we are heading with these advances. But more importantly, as future engineers and the industry leaders, we must critically assess the road ahead. What kind of world are we designing with this incredible power? How do we ensure that the technologies we create are inclusive, ethical, and sustainable? And most importantly, how do we prepare ourselves to wield such transformative tools responsibly? The humble beginnings. The GPU evolution. Let's start at the beginning. In the 1980s and 1990s, the demand for better graphics in video games gave rise to graphics processing units. Initially, these chips were designed for fixed operations like rendering simple 2D and 3D images. Products like the 3D FX Voodoo and NVIDIA Riva revolutionized gaming, making it more immersive. For gamers, this was transformative, enabling smoother animations and realistic textures, but for engineers and scientists, these same innovations hinted at untapped potential. The real breakthrough came in 1999 with the launch of NVIDIA's GeForce 256, the world's first GPU capable of transforming and lighting 3D objects. It marked the start of a new era in visual computing. Suddenly, GPUs weren't just tools for gaming, they were the cornerstone of visualization, simulation, and more. The introduction of programmable shaders in the early 2000s was another milestone. These allowed developers to customize the rendering process, giving rise to realistic graphics that push the boundaries of video games, movies, and even scientific visualization. Remember movies like Avatar? GPUs made those breathtaking visual effects possible. And then came the game changer, CUDA, introduced by NVIDIA in 2006. CUDA enabled developers to harness GPUs for general purpose computing tasks, unlocking their potential for fields like cryptography, fluid dynamics, and most notably, artificial intelligence. By then, GPUs had evolved from gaming hardware to essential tools for computational science. So it's fascinating to think about how these technical milestones shape not just technology but our culture. From games to movies to scientific breakthroughs, GPUs have been at the heart of it all. GPUs and the rise of artificial intelligence or the AI. Fast forward to today, and GPUs are the unsung heroes of artificial intelligence. Why? Because training AI models is an incredibly resource-intensive task. Traditional CPUs, designed for sequential processing, simply couldn't keep up. GPUs, however, excel at parallel processing, making them perfect for handling the massive computations required for deep learning. Consider this. Training a large neural network involves millions, sometimes billions of operations. GPUs make this possible by processing data in parallel across thousands of cores. They have accelerated breakthroughs in natural language processing, computer vision, and more. For instance, the GPT models, the very AI that powers this reflection, were trained on, were trained on massive datasets using GPU clusters in state-of-the-art data centers. Without GPUs, such models would take years, not weeks to train. Beyond training, GPUs enable real-time AI deployment. Think of autonomous vehicles. Every second, this vehicle processes the data from cameras, radars, and sensors to make split-second decisions. It's the GPS speed and efficiency that make this possible. In healthcare, GPUs power algorithms that analyze X-rays, MRI scans, and genetic data, enabling earlier diagnosis and better patient outcomes. From predicting natural disasters to optimizing global logistics, GPUs have become the backbone of AI's impact on society. It's awe-inspiring to think that the technology designed for games now powers life-saving innovations, but it also reminds us the unpredictability of progress, a lesson in the importance of keeping an open mind as engineers. Beyond AI, Digital twins and the metaverse. As GPUs grows more powerful, they are opening doors to technologies we once considered science fiction. One of the most fascinating is the concept of digital twins. A digital twin is a virtual replica of a physical entity, whether it's a car, a factory, or an entire city. With GPUs, we can create simulations so accurate they mirror real-world behavior. Imagine a factory using a digital twin to optimize production lines in real time, or a city simulating traffic to reduce congestion and energy use. The metaverse too also its potential to GPUs, rendering immersive interactive environments in real time requires extraordinary computing power. GPUs make it possible for millions of users to experience these virtual spaces simultaneously, whether they are working, socializing, or creating. Companies like Nvidia, Epic Games, and Meta are investing heavily in these technologies, envisioning a future where physical and virtual reality seamlessly blend. But the metaverse also raises important questions. Who owns these digital spaces? How do we protect privacy and ensure equitable access? And how do we prevent these environments from exacerbating existing inequalities? These are challenges we'll need to address as we build this future picture. Challenges and opportunities ahead. The rapid development of GPUs and their applications brings both opportunities and challenges. One major challenge is energy consumption. High performance GPUs are power hungry, and as we build larger AI models and simulations, their environmental impact grows. Data centers housing GPUs consume massive amounts of electricity, raising concerns about sustainability. For example, the energy footprint of training a single large AI model can be equivalent to the annual energy consumption of several households. This highlights the need for urgent innovation. Companies like Nvidia and Google are already exploring energy efficient chip designs, while some data centers are transitioning to renewable energy sources like solar, wind, and geothermal power. But the question remains, can these advancements scale fast enough to offset the growing demand for computational power? Another approach gaining traction is optimizing AI models themselves. By creating smaller, more efficient models that require fewer resources to train and run, we can significantly reduce the environmental cost of innovation. This combination of hardware and software optimization could lead to a more sustainable computing future. Then there's the ethical dimension. As AI becomes more pervasive, how do we ensure its used responsibly? GPUs enable tools like facial recognition and predictive analysis, but in the wrong hands, these technologies could infringe on privacy, amplify surveillance, or perpetuate bias. Consider instances where AI systems have been found to disproportionately target certain demographic groups. These issues underscore the importance of transparency and fairness in AI systems. This is where frameworks for ethical AI come into play. Governments, academic institutions, and tech companies are collaborating to establish guidelines and standards that promotes accountability in AI development. But this is a global issue, and it requires collective effort. How can we create a unified set of principles that reflect the very diverse cultural, legal, and moral values of our interconnected world? As future engineers, it's our job not only to innovate but to anticipate the ripple effects of our creations. The choices we make today will shape the world of tomorrow. But let's also focus on the opportunities. GPUs are driving breakthroughs in quantum computing, where they work alongside quantum processors to tackle problems once thought unsolvable, like climate modeling and drug discovery. They are also empowering researchers and startups in underrepresented regions by providing access to cutting-edge computational tools through platforms. In essence, the challenges and opportunities are two sides of the same coin. The power of GPUs reminds us that every technological leap comes with responsibility. By working together as engineers, policymakers, and global citizens, we can ensure these technologies drive progress for everyone. Conclusion. As we reflect on the journey of GPUs, from humble beginnings to their role as enablers of global innovation, one thing is clear. These technologies redefine what's possible, but with great power comes great responsibility. The future of AI, digital twins, the metaverse, and other technologies will depend on how thoughtfully we design and deploy them. As future engineers and leaders, we must ask ourselves, are we building technologies that align with our values? Are we considering the societal, ethical, and environmental implications of our work? The future is unwritten, but one thing is certain. It will be shaped by those with a vision and courage to lead. Let's create a world where technology empowers everyone and leaves no one behind.